Hello and welcome back to EpiSTEM, everybody. So today we're not going to be doing what we usually do where we dive into a paper. Today we'll actually be interviewing an entrepreneur. This entrepreneur we're going to be talking to, he works with a company, a startup company that is involved in promoting sustainability. And you'll see exactly how when we get into it. But we hope you enjoy it. We certainly had a good time recording this episode. So without further ado, let's get into it.
I'm Hunter.
And I'm Luke, and you're listening to EpiSTEM, a show where we explore papers in STEM fields and let you know what they're all about. So we mentioned that we're talking to an entrepreneur today, but we should first talk about his company. So the name of the company that this guy works for and works with, it's a startup company called GroPod. So how would you describe GroPod in your own words?
I would describe it essentially as a Keurig for plants. So it looks like a little mini fridge with a white cylinder in the middle where these grow pods, which are like K-cups, are put into the slots, and then from there the hydroponics act on the system and give water and nutrients to the plants that allow them to grow and flourish. This can be utilized to help in personal fields such as someone's home or industrial farming, which we'll talk about later in the episode. We've been following this company for a couple of years and have really seen it grow over the last few years. And beyond that, the industry for hydroponics in general is growing immensely. The way that hydroponics works is that they utilize a water redistribution system to give plants water and nutrients with using less of that water than standard farming methods.
One of the really attractive things about this is that the whole process of growing a plant with the GroPod system is pretty automated. So I personally have never been good at really growing plants on my own. I just don't have that green thumb that everybody else seems to have. Sometimes it seems like I can grow a cactus, if that counts. But the thing about this is that, like I said, it's automated. So they've already done all the hard work in making sure the plant's getting the light it needs, getting the water it needs. And it's an added bonus that it fits inside your house about the size of a mini fridge and doesn't really require much oversight and uses less energy and less water than traditional farming. Less space, too.
But we were curious as to where this company started and how they grew to where they are now.
Yeah, it was came out of nowhere actually.
The voice you're hearing right now is Ivan Ball. He's one of the guys who started this company while he was in college studying electrical and computer engineering technology and is still with it today.
I was just your typical broke student that on campus trying to look for a job to just pay for whatever fun hobbies you had while you were there, and then I wanted something that was relevant to engineering experience so you could use it later for interviews or whatever to get a job, and ended up finding this job at the horticulture college, which at the time I was kind of like, plants, what? I don't know if I want to deal with that. But it was an electrical engineering position where I had to design, build, test data acquisition systems to measure sensor data that was coming in side of a controlled environmental chamber that was growing plants using the method of hydroponics. And at this time, I had no idea what hydroponics was or how it worked. Really didn't even know about plant cultivation much besides my parents' gardening. And then I came from a rural farming community, just soil crops with corn and wheat. But as we dove into that, I realized that the project we were working on was actually funded by NASA. It was a NASA grant through the Purdue Horticulture College. So that kind of struck my interest just because I was kind of a physics space nerd at the time. And so that when that sparked me a little bit, I started looking into more about hydroponics and plant growth, and realized the technology to actually automate plant growth only happened in the past 5 years.
Ivan saw the vision that LEDs would be the future of plant growth and other industries, so he decided to pursue more research into the LED field.
With LED technology becoming so cheap, single board computers like the Raspberry Pi was available to pull in all the sensor data and process everything. And then you also had a lot of people building these open source libraries where you could quickly pull all this together. The idea that you could fully automate plant growth started sparking ideas with myself and my partner Scott Massey, which was also, he's a mechanical engineer from Purdue also. We worked together on that project. And he actually came up with the initial drawings of kind of the design and format of how this thing would work. And what we had and we were working on was more of a flat tier, plain, horizontal, stacked tiered system, which is typically what you see today also. But it really hasn't changed much. And our form factor that we came up with was to optimize the amount of space that we could grow plants inside of a controlled chamber. So it's a sealed chamber where you create a positive pressure to keep pests out of. That way you could also control temperature and humidity from a control system. Change your LED lights up and down to optimize plant growth. And then you also control the watering cycles with a pump. So it was pretty simple, but once you started diving into it, the plants, they would fail and die. So we didn't really start with a green thumb. It took many iterations of trial and error and failures to actually figure out how to grow the plants. But it was that project at Purdue that actually kicked things off for us that eventually led to this startup company that we have, where it was actually Scott that put down the first patent for what we call now as rotary aeroponics, which was our design using a cylindrical tower inside of a controlled chamber, like I said, to optimize the amount of space that plants could grow on. And then once that patent was down, we started just building a business around it.
At the time Ivan was getting involved in this project, a lot of technologies were in their infancy. As you might have heard, NASA was funding the project he was working on, which is a pretty big name. But what about this technology was so special?
It was mainly the LEDs themselves. So LEDs got significantly more efficient. People started adopting them a lot in automotive applications. Once the automotive industry started taking off with LEDs, the price just dropped where they started putting them in other applications like these grow lights for horticulture.
With this ever-advancing technology, we were wondering where GroPod really stood. Are they on the forefront, or are they on the heels of other companies?
So this project that we were working on was one of the leading projects for this type of technology, which is basically using different colors of LEDs to manipulate different phytochemical, physiological changes of plants. So if you add more red light, it actually elongates the plants a little bit more, and if they're flowering, it quickly probes them to flower quicker. Whereas blue light would actually generate a lot more biomass, but you have a more compact plant, and that's mainly with lettuce. So every single plant type reacts differently to different colors of light. So you have to do all these research trials only using a specific type of plant with different types of color recipes is what we called, mixtures of red, green, blue, white, and then you would just collect all this data, and then you would harvest, measure the dry weight of it, the fresh weight of it, generate these reports and try to find your learnings of, okay, which light recipes were the most efficient and which ones contributed to the most yield to energy ratio. So the most yields, grams per kilowatt hours, what we go by. So the more grams using the fewest kilowatt hours is really what we strive to do.
We were wondering how different intensities of light and different colors of light actually affect the plants and how they affect them at different points in their life cycle.
Different growth stages require different amounts of light and different colors of light. So this is relevant a lot for flowering plants. You want just a lot more reds and whites near the end of the life, whereas at the beginning it's beneficial to have some more blue just for like the leaf structure and growth of the plant stem itself. So yeah, there is a lot of research going in right now towards not only changing up the light colors as you grow through the different stages, but also for us specifically, we added a rotational mechanism to it. So you can imagine like a rotisserie chicken over a heating element, you get uniform heat over the entire chicken, even though you only have one heating element. That's similar to what we do, where we have two stationary LED bars and we'll rotate the tower. But now we've thrown in this rotational factor where we're actually ramping up the speed up and down, not only changing colors and turning the LEDs on and off at different photo periods, but now spinning the tower quicker or slower. So there's a lot of different variables we do research on.
So thanks to a creative use of LEDs, in an optimized rotary style design, they're able to produce and grow plants at maximum efficiency. But this technology can certainly go in other directions.
If you think about any type of light source that could be applied inside of an appliance, you could manipulate the lighting in such ways to actually change the physiology of plants, where you could control the taste, flavor content, and that could all be adjusted through software and feedback from our apps to actually build personal profiles for people to grow their favorite type of basil that is slightly sweeter by generating the specific microclimate that allows it to be harvested, that flavor.
We're going to go ahead and take a quick ad break. Maybe consider what you would do if you had this sort of technology where you could customize the flavor of your basil or of your mint. What would you do with that? Anyways, see ya after the break. Welcome back. So before the break, we talked about the technology of GroPod, how they're utilizing really creatively designed LED lights to optimize plant growth. Turns out you can use these lights to alter the flavors and the growing characteristics of plants while they're growing. But now we're going to get a little bit more into how GroPod compares to traditional farming and some of the implications it has in other components of the economy.
We've come up with the metrics of grams per kilowatt hour, and in that metric, we're 3 times more efficient than traditional farming. By that, I mean the amount of yield. So we have more plants compact in a smaller space, so we just get a lot more output. And whenever I told you we have that rotary mechanism turning amongst 2 LED lights, typically you would need 4 LED lights, so double the amount of lighting, just to even get uniform growth around a cylindrical tower design similar to ours. But right now everyone else is using horizontal planes, so they haven't even gotten the optimized space to grow as many plants as we have. So we have a wine cooler frame size appliance, and it can grow up to 60 plants, and it all fits under your cabinetry in your kitchen. It's a lot more efficient, not only electrically, but water as well. So we use 95%, sometimes even more, less water than traditional farming, which is like out in the field where you can see sprayers running, and there's just a lot of fertilizer runoff associated with that, where we have virtually no fertilizer runaway because we're constantly recirculating the water over the roots until it's fully absorbed. And then another big point is food waste. So when you harvest something in a field, there's obviously a lot of waste just when you're harvesting. Then to get it into a truck, to get it packaged, to get it washed, to get it shipped, and then the storage time where it sits in a refrigerator, there's waste associated with that. And then the biggest waste comes in the last mile, where it sits in the grocery store on a shelf, and then it ends up in your home. And there's been studies done on this where nearly 40% of all produce is thrown away just in the consumer's home before they can eat it. So it just goes bad too quickly before anyone can actually eat it. That amount of produce actually contributes to a lot of greenhouse gas emissions, and specifically methane gas.
We were wondering, what's different about GroPod compared to any other traditional farming or other hydroponic methods?
With our system, basically, you're virtually eliminating food waste completely by what we do is we have subscription seed pod model, where you get these like kind of little K-cups of seeds, and you put them into our system. We fully automate the growth, so it's a dry, non-perishable good that we ship to you, where we eliminate that basically high perishable good that you would get at a grocery store.
So given that this technology is pretty small and composed of pretty simple components such as motors, LEDs, and just a software package, are there any limits to where in the globe you can produce it, or in what conditions it has to be produced under?
It's funny because we actually started the company, we had a 3D printed growth tower inside, just because the cost to mold those parts is very expensive and we didn't have the capital to do it. So we had 4 3D printers running full time, just printing these parts to prepare for building our units for our early adopters. So yeah, it's actually very possible you could 3D print these towers and grow not only indoors but outdoors. And that's actually something Scott has been leading for our company, where he works with outdoor farms in Africa, and they build these towers or vertical farms outdoors to grow produce for local villages there.
You talked about the implications of GroPod in Africa, but what are some uses of GroPod in America with some domestic issues such as water scarcity?
Yeah, actually, that's a good point to bring up, because California is very dry and it's on fire right now. And that's where
Yeah.
almost 60 to 70% of our produce comes from that region. It's partially Arizona, California, and it's all shipped across the U.S. And they're struggling actually right now a lot with not only water, but there's a lot of labor shortages just because of the impacts of COVID. And they just can't get a lot of people into the fields. Even though there's produce available in the fields, they're unable to harvest it. So there's a lot of concern that the price of food may start to increase here soon.
There will always be opportunities for entrepreneurs to thrive as long as they're willing to put in the hard work that it takes, whether they're motivated by a crisis or not. So what advice would you give to somebody who is trying to develop an idea or a product?
I would say, one, you definitely want to do your research. Make sure if what you're doing is already an idea that's out there and you're going to be competing with a lot of people, it's going to be just very difficult. So if you really do have a novel, true, like original idea, it'll make it a lot easier. Once you have that genuine idea, then building your team, I'd say, is the most important initial step. You don't want to do this all by yourself unless you're just completely loaded and you have cash, you can throw it around. But in our case, we were two broke college students going to business plan competitions, which I would also highly recommend. Showing off your technology, trying to get as much free grant cash money as possible. But initially you want that team, and your team members specifically need to have a balance of strengths and weaknesses, and like Scott's strengths balance out my weaknesses and vice versa. So like we work really well together, because if there's something he can't do, usually I make up for it and can do it. And then there's a lot of things he also does as well for me. That's, I would say, one of the biggest steps is the team. Also, if you don't believe in what you're doing, you're just going to get burnt out. So you have to genuinely enjoy and love what you do. And with this technology, that's why we've gotten as far as we have, is because we both really believe this is possible and could be in everyone's home and allow anyone to be a farmer. And it's also just got a lot of sustainable benefit behind the technology itself versus kind of the farming methods we use today.
To conclude this episode, can you summarize what GroPod's goal is and where you see it going in the future?
So our actual mission is to fully decentralize as much of the perishable good industry of agriculture as possible. So mostly your leafy green vegetables. There are some fruiting and flowering varieties we could also put into the system. But we really want to enable anyone, anywhere, to be their own farmer. And the more you decentralize this, the bigger the impact on sustainability you have worldwide. And there's a point where we will sell, hopefully, enough of these units where we will start competing with some of these actual larger outdoor farms. And in the grand scheme of things, say 10 years down the road, whatever it might be, we really hope to be the world's largest farming company without owning any land. And just having the software technology run our appliances and shipping out these like seed pods in the mail directly to your home.
And that brings us to the end of today's episode. Turns out farming may look very different in the future than what we are used to. If you liked this episode, or if you didn't like it, feel free to reach out to us at epistem.pod@gmail.com.
Also, feel free to follow us on Instagram at epi.stem.
If you got a little extra money in your pockets and it's just burning a hole, feel free to go to Patreon at patreon.com/epistem and let us know how we're doing on there. So what would you do if you had one of these? I think I would make basil taste a little bit minty.
I'd probably make my spearmint like peppermint.
I think I would want my carrots to be, a little bit fluffier.
I might want my tomatoes squishier.
Squishy tomatoes, huh? I want my tomatoes to taste like carrots.